Hello guys, this video is about intermediate value theorem. So let's take a look at the figure. In a continuous function, if the function f is continuous over the interval a to b, and the signs of f of a and f of b are opposites, then there is a root between them. So the function is continuous from a to b, and f of a is negative, f of b is positive, then there is a solution, a root between between a and b. So there is a value that makes function 0. So f of c is equal to 0. The questions will ask us to find the values where the function is 0, or the questions will give us the values, two values, and ask about the function which has a root between those two given. So in either case, we are going to check continuity first. So our function should be continuous in order to have a root between them. So the first step is always checking the continuity. Second step is checking the sign of f of a and f of b. Let's take a look at the question. First question. All right. So use IVT to prove that equation has a root between 0 and 1. So the first step is always checking continuity. Check continuity. So what kind of function do you see here in the question? The given function is polynomial. Since we have polynomial functions are continuous everywhere. So we are sure that our function is continuous between 0 and 1. Okay, we can continue with the second step. Second step, check the signs. Whose signs we are going to check? We are going to check sign of f of 0, the given numbers, and f of 1. What is f of 0? 0 to the fourth plus 2 times 0 squared minus 1 minus 1. What is f of 1? 1 to the fourth plus 2 times 1 squared minus 1, which is 1, 2, 3, 3 minus 1, 2. So f of 0 is negative, while f of 1 is positive. So I have two opposite signs, just like this graph. One of them, f of a is negative, f of b is positive. So I'm sure that since it's continuous function, there must be a root between them. There must be a value that makes the function 0. So this is how I do the proving. Okay, so if it is a multiple choice question, in options you'll have you'll either be given these numbers, the function will be asked, or the function will be given, the numbers will be asked. Let's take a look at some ministry questions and see how the questions come in exam. So here, the first type, the function is given. You're asked to find two numbers where the function has a root between them. And the next question, two values are given. The correct function is asked, that has a root between those two. Okay, the questions will come either this way, function given, numbers asked, or numbers given, function asked. There are two types of questions. Okay, first type, function is given. In either case, the first step would be always checking the continuity. So what is the point of this continuity for that function? So that we exclude, we eliminate that option, the option that has the point of discontinuity of this function. So it's a rational expression. So let's check the denominator. Remember, point of discontinuity is the number that makes denominator 0. What is denominator? 2x cubed plus 16. What makes 2x cubed plus 16 0? 2x cubed equals negative 16. Divide both sides by 2. x cubed is negative 8. Take cubic root of both sides. X is equal to negative 2. So the function is discontinuous at x equals negative 2. So I got point of discontinuity. So in options, I'll check in which option we have this number. We will eliminate those options. Do you have negative 2 between them? No negative 2 in option A. Do you have negative 2 between negative 3 and negative 2? Yes, between negative 3 and negative 1, there is negative 2. So function is discontinuous on this interval, so B can't be true. Option C, do you see negative 2? Yes, there is negative 2. So function is discontinuous over that interval. Our answer cannot be C. Option D, there is no negative 2. So I am done checking continuity. I am done with the first step. I eliminated two options. Let's proceed the second step. Second step, check signs of f of what? F of 0 and 1 in option A. Let's go option by option. Check option A first and check option D. Option A, what is f of 0? What is f of 1? Do they have opposite signs? If they have opposite signs, then there's a root between them. It's our correct answer. If not, it's not our correct answer. Okay, f of 0. 0 minus 3 divided by 0 plus 16, 16. F of 1. 1 minus 3 minus 2 divided by 1 times 2, 2, 2, 16, 18. So, when you check the results, f of 0 is negative while f of 1 is also negative. So, they have same signs. Same signs won't give us a root between them. So, option A cannot be true. Option A cannot be true either. So, our answer must be D. Let's make sure. When you check D, you are going to check the sign of f of what? 1 and f of 2. F of 1, I already got it in the previous part, negative 2 over 18. F of 2, 2 cubed, 8, 8 minus 3, 5, divided by 2 cubed, 8 times 2, 16, 16, 16 makes 32. So finally, f of 1 is negative, f of 2 is positive. I have opposite signs, so that checks. That's my answer. That's what I am looking for. Function is continuous over this interval between 1 and 2, and f of 1 and f of 2 have opposite signs, so that's exactly what I'm looking for. All right. This is the first type of question. Function is given, numbers are asked. Second type of question, numbers are given, function is asked. So still, I'm going to check continuity first. So continuity of what? Continuity of every option, one by one, we should check. The first one, it's rational. What makes denominator 0 is point of discontinuity. So x equals 0 is point of discontinuity. So is 0 in this given interval? Yes, 0 is between negative 2 and 3. So function is discontinuous over this interval. So there is no root between those two numbers then. So option A is false. You eliminate option A. Alright. What about option B? What makes denominator 0? 2. So x equals 2 is point of discontinuity. Is 2 between negative 2 and 3, the given numbers? Yes, it is. So then unfortunately, the function doesn't have a root between them because function is discontinuous over that interval. So option B is false. Option C, f of x minus 1 x squared plus 1, check denominator, x squared plus 1. There is no value that makes denominator 0. when x squared plus 1 is 0, x squared is minus 1, which is impossible, so no point of discontinuity. No discontinuity point. So this checks, it is continuous everywhere. Option D, polynomial, continuous everywhere. So our answer is either C or D. Let's check the signs of f of negative 2 and f of 3 for both options. Option C and option D, one by one. Okay, option C. Let's check f of negative 2 and f of 3. F of negative 2, negative 2, negative 1, negative 3 divided by negative 2 squared, 4, 4, 1 makes 5, so that's a negative result. What about the next one? F of 3, 3 minus 1, 2, divided by 3 squared, 9, plus 1, 10. 2 over 10 is a positive result. So I have opposite results. So it checks. Then C is my answer. The function is continuous over this interval, and the signs of f of negative 2 and f of 3 are opposite, so that's our answer. Just to show you, let me do d2, d f of negative 2, negative 2 squared, 4, 4 times 2, 8, 8 minus 5 times negative 2, 10, 10, 8, 18, plus 1, 19, so the result is positive. F of 3, 3 squared, 9, 9 times 2, 18, 18 minus 5 times 3, 15, so 3 plus 1, 4, which is also positive. So they are both positive, same result, which can't be true. Alright, so that's not our answer either. Our answer is C. See, the questions are simple. When you know the idea, solving questions doesn't need a lot of stuff. Finally, one last question, 2023 second attempt ministry question. Number is given. Which function has a root between them? So it means which function is continuous over this interval, and f of negative 1 and f of 1 are opposite signs. First, check continuity. So, the first option, x squared plus 1 in denominator, there is no number that makes denominator 0, so it's continuous everywhere. Option B, polynomial, so continuous everywhere. So if it is continuous everywhere, then it's continuous over this interval too. Option C, x, denominator is x, so what makes denominator 0? 0. So x equals 0 is point of discontinuity. Function is discontinuous at 0, and 0 is between negative 1 and 1. So if that function is discontinuous over that interval, there is no root between them. Option D, what's point of discontinuity? There's a root, so the under root, stop under root should be greater than or equal to 0, right? So 3 is greater than or equal to 2x, divide both sides by 2, 3 over 2 is greater than or equal to x. This is where function is continuous, so the opposite is point of discontinuity. X is greater than 3 over 2. Here we have x is less than or equal to 3 over 2. The opposite is x being greater than 3 over 2. So this interval is point of discontinuity. So do you have numbers between negative 1 and 1 here? No. 3 over 2 is bigger than 1, so it's not in that interval. So function is continuous. That function is continuous over the given interval between negative 1 and 1. So I only eliminated option C. Unfortunately, I have 3 more options to go. So I'll check every option one by one to see if the signs are opposite. So option A. Option A. What is f of minus 1? It is minus 1 over 1, 1, 2. It is negative. What is f of 1? It is 1 over 1, 1, 2. This is positive. Negative, positive. I have two opposite signs. So it checks. Option A is true. I'm lucky. First option is true. But just to show you, I will check the other options too. Option B, f of minus 1, minus 1, minus 5, minus 6. F of 1, 1 minus 5 minus 4. They are both negative, same sign, which can't be true. Option D, f of negative 1, 3 minus 2 times negative 1, 2 2, 3, 5 square root of 5, which is positive. What is f of 1? It is 3 minus 2, 1, square root of 1, 1, which is also positive. Option B, they are both negative. Option D, they are both positive. So we don't have a root between negative 1 and 1 because they have same signs. Then only correct answer is A. So ladies, this is the way. First, checking the continuity. Second, checking the sign of f of A and f of B, the given numbers.